Once the walls and ceilings are open, thoroughly inspect all wiring for damage. Look for any visible signs of burning, melting, or discoloration. Check for any evidence of insulation damage, such as cracking or blistering. Test all outlets, switches, and lights for functionality. Whether to rewire the entire house or perform partial repairs depends on several factors. Firstly, consider the extent of damage. If the majority of the wiring is damaged or compromised, a whole house rewiring is likely necessary. Secondly, consider safety concerns. Replacing damaged wiring with arc fault circuit interrupter, commonly known as FSI, breakers will provide enhanced safety, but if there are significant fire hazards, a whole house rewiring is recommended. Thirdly, consider code compliance. Local building codes may require a whole house rewiring after a fire. Finally, consider the cost. A whole house rewiring is typically more expensive than partial repairs. Now let's review partial repair considerations. Isolate damaged areas. Disconnect and remove any wiring that shows signs of damage. Replace damaged wiring. Install new wiring in place of the damaged sections. Upgrade to arc fault circuit interrupter, commonly known as FSI. Install arc fault circuit interrupter, commonly known as FSI, breakers in the electrical panel. Test and verify. Ensure all replaced wiring is functional and meets code requirements. Now let's discuss whole house rewiring considerations. Remove all existing wiring. All old wiring should be removed, including wires in walls, ceilings, and fixtures. Install new wiring. Run new wiring throughout the house, ensuring it complies with current electrical codes. Upgrade to arc fault circuit interrupter, commonly known as FSI. Install arc fault circuit interrupter, commonly known as FSI, breakers in the electrical panel. Test and certify. Have a licensed electrician inspect and certify the new wiring installation. Based on the description of the house, it appears that a partial repair may be sufficient. However, it's crucial to thoroughly inspect the wiring once the walls and ceilings are open to determine the extent of damage and ensure the safety of the occupant. If there is any doubt about the condition of the wiring, it's advisable to consult with a licensed electrician to assess the situation and recommend the appropriate course of action. Now let's delve into some technical aspects related to electrical wiring and safety in residential buildings, particularly focusing on situations involving fire damage. Electrical wiring in residential buildings typically consists of several components, including conductors, insulation, and protective sheathing. The conductors are usually made of copper or aluminum, which provide a path for electrical current to flow. The insulation is a non-conductive material that surrounds the conductors to prevent electrical shorts and shocks. The protective sheathing provides additional protection against physical damage and environmental factors. When a fire occurs, the wiring can be subjected to extreme heat and flames, which can cause significant damage to the conductors, insulation, and sheathing. The heat can melt or burn the insulation, exposing the conductors and creating a risk of electrical shorts and shocks. The flames can also damage the conductors, reducing their ability to carry electrical current. In addition, the smoke and soot from the fire can contaminate the wiring, making it difficult to determine the extent of the damage. Therefore, it is essential to thoroughly inspect all wiring after a fire to identify any damage and ensure the safety of the electrical system. Arc fault circuit interrupters, commonly known as FSIs, are a type of circuit breaker that is designed to protect against electrical fires caused by arc faults. Arc faults occur when there is an unintended electrical discharge between two or more conductors. These discharges can generate high temperatures that can ignite nearby combustible materials, leading to a fire. Arc fault circuit interrupters, commonly known as FSIs, work by detecting the unique characteristics of arc faults, such as the high frequency noise and irregular current flow. When an arc fault is detected, the arc fault circuit interrupter, commonly known as FSI, quickly trips the circuit, interrupting the flow of electricity and preventing a fire. Arc fault circuit interrupters, commonly known as FSIs, are typically installed in the electrical panel and are required by the National Electrical Code, commonly known as NEC, in many areas for certain circuits, such as those that serve bedrooms and living rooms. When considering whether to repair or rewire a fire-damaged house, it is important to understand the relevant electrical codes and standards. The National Electrical Code, commonly known as NEC, is a widely adopted set of standards for the safe installation of electrical wiring and equipment in the United States. The National Electrical Code, commonly known as NEC, provides detailed requirements for the type and size of conductors, the installation of wiring methods, and the protection of electrical circuits. Local building codes may also have additional requirements that must be followed. For example, some local codes may require a whole house rewiring after a fire, regardless of the extent of the damage. It is essential to consult with a licensed electrician and the local building department to determine the applicable codes and standards for the specific situation. When performing a partial repair of fire-damaged wiring, it is important to follow these steps to ensure safety and code compliance. Firstly, isolate the damaged areas by disconnecting the power to the affected circuits at the electrical panel. Secondly, remove any wiring that shows signs of damage, such as burning, melting, or discoloration. Cut the damaged wires back to a point where the insulation is clean and undamaged. Thirdly, install new wiring in place of the damaged sections, using the same type and size of conductors as the original wiring. Fourthly, make sure to properly splice the new wiring to the existing wiring, using approved connectors and methods. Fifthly, upgrade to arc fault circuit interrupter, commonly known as FSI, protection by installing arc fault circuit interrupter, commonly known as FSI, breakers in the electrical panel for the affected circuits. Sixthly, test and verify the repaired wiring to ensure that it is functional and meets code requirements. Use a multimeter to check for continuity and voltage, and a circuit tester to verify that the outlets are properly wired and grounded. When performing a whole house rewiring, it is important to follow these steps to ensure a safe and reliable electrical system. Firstly, disconnect the power to the entire house at the main electrical panel. Secondly, remove all existing wiring, including wires in walls, ceilings, and fixtures. Thirdly, install new wiring throughout the house, ensuring that it complies with current electrical codes. Use the appropriate type and size of conductors for each circuit, and follow the National Electrical Code, commonly known as NEC, requirements for wiring methods and protection. Fourthly, make sure to install new outlets, switches, and light fixtures throughout the house, choosing products that are listed by recognized testing laboratories such as Underwriters Laboratories, commonly known as UL. Fifthly, upgrade to arc fault circuit interrupter, commonly known as FSI, and ground fault circuit interrupter, commonly known as GFCI, protection by installing arc fault circuit interrupter, commonly known as FSI, breakers in the electrical panel for the appropriate circuits. Sixthly, test and certify the new wiring installation to ensure that it is safe and meets code requirements. Have a licensed electrician inspect the wiring and perform the necessary tests, such as a ground resistance test and an insulation resistance test. In addition to the technical aspects of electrical wiring and safety, it is also important to consider the psychological impact of a house fire on the occupants. A fire can be a traumatic experience that can leave people feeling stressed, anxious, and overwhelmed. It is important to be sensitive to the emotional needs of the occupants and to provide them with support and resources to help them cope with the aftermath of the fire. This may include providing information about insurance claims, temporary housing, and mental health services. Furthermore, effective communication is crucial throughout the repair or rewiring process. Keep the occupants informed about the progress of the work, any unexpected issues that arise, and the estimated timeline for completion. Be responsive to their questions and concerns, and address any issues promptly and professionally. By addressing both the technical and emotional aspects of a house fire, you can help the occupants to recover and rebuild their lives. The process of inspecting and assessing fire-damaged wiring involves several key steps. The primary goal is to determine the extent of the damage and ensure that the electrical system is safe for use. Here is a detailed breakdown of the inspection process. Firstly, safety precautions before beginning any inspection. Ensure that the power to the affected circuits is turned off at the main electrical panel. This prevents the risk of electrical shock during the inspection. Use a reliable voltage tester to confirm that the power is indeed off. Secondly, visual inspection. Thoroughly examine all visible wiring, outlets, switches, and light fixtures. Look for signs of damage such as burned or melted insulation, charred wires, discoloration, and physical deformities. Pay close attention to areas where the fire was most intense, as these are likely to have the most damage. Thirdly, insulation testing. Insulation damage is a common issue in fire-damaged wiring. Use an insulation resistance tester, also known as a megometer or megger, to test the integrity of the insulation. This device applies a high-voltage direct current, commonly known as DC, to the wire and measures the resistance. Low resistance indicates damaged insulation. Compare the readings to the manufacturer's specifications or industry standards to determine if the insulation is still viable. Fourthly, continuity testing. Use a multimeter to perform continuity tests on the wiring. This test checks whether the electrical path is intact. Disconnect the wire from the circuit to avoid false readings. A lack of continuity indicates a break in the wire, which means it needs to be replaced. Fifthly, outlet and switch testing. Inspect all outlets and switches for damage. Use a circuit tester to check for proper wiring, including correct polarity and grounding. Replace any outlets or switches that show signs of damage or do not pass the circuit tester's tests. Sixthly, junction box examination. Open all junction boxes to inspect the wiring connections. Look for loose connections, corrosion, or any signs of overheating. Ensure that all connections are properly tightened and that the wires are securely fastened within the box. Seventhly, conduit and cable pathway assessment. Check the condition of conduits and cable pathways. Ensure that they are free from physical damage that could compromise the wiring. Look for signs of melting or deformation in plastic conduits. Eighthly, assign GFCI testing. If the home is equipped with arc fault circuit interrupters, commonly known as FSIs, and ground fault circuit interrupters, commonly known as GFCIs, test these devices to ensure they are functioning correctly. Press the test button on each breaker or receptacle. The device should trip, cutting off power to the circuit. If it does not trip, the device needs to be replaced. Ninthly, documentation. Keep a detailed record of all findings, including photographs of any damage. This documentation will be helpful for insurance claims and for planning the repair or rewiring work. Tenthly, professional consultation. If you are unsure about the extent of the damage or lack the expertise to perform the inspection, consult with a licensed electrician. A professional can provide a thorough assessment and recommend the appropriate course of action. After the inspection, you will need to decide whether to repair the damaged wiring or to rewire the entire house. Here are some factors to consider when making this decision. Firstly, extent of the damage. If the damage is limited to a small area and the majority of the wiring is in good condition, a repair may be sufficient. However, if the damage is widespread, a whole house rewiring is likely necessary. Secondly, age of the wiring. Older wiring may have deteriorated over time, even if it was not directly damaged by the fire. In such cases, rewiring may be a better option to ensure long-term reliability and safety. Thirdly, code compliance. Electrical codes change over time. Rewiring provides an opportunity to bring the electrical system up to current code standards, which can improve safety and increase the value of the home. Fourthly, safety considerations. Even if a repair seems feasible, rewiring may be the safer option, especially if there are concerns about hidden damage or the long-term reliability of the existing wiring. Fifthly, cost. While rewiring is more expensive than repairing, it may be more cost-effective in the long run if it prevents future problems and improves the overall value of the home. If you decide to repair the damaged wiring, here are some best practices to follow. Firstly, use appropriate materials. Use only electrical components that are listed by a recognized testing laboratory, such as Underwriters Laboratories, commonly known as UL. Make sure that the replacement wiring is of the same type and gauge as the original wiring. Secondly, follow code requirements. Adhere to all applicable electrical codes and standards. This includes using approved wiring methods, properly grounding all circuits, and installing arc fault circuit interrupters, commonly known as FSIs, and ground fault circuit interrupters, commonly known as GFCIs, as required. Thirdly, make secure connections. Ensure that all wiring connections are tight and secure. Use approved connectors and splicing techniques to prevent loose connections, which can cause overheating and electrical fires. Fourthly, protect the wiring. Protect the wiring from physical damage by using conduit or other protective measures. Avoid running wires through areas where they could be easily damaged, such as near sharp edges or in high traffic areas. Fifthly, test and verify. After completing the repair, test the wiring to ensure that it is functioning correctly. Use a multimeter to check for continuity and voltage, and a circuit tester to verify that the outlets are properly wired and grounded. If you decide to rewire the entire house, here are some additional considerations. Firstly, planning and design. Develop a detailed plan for the new wiring system. This should include the location of all outlets, switches, and light fixtures, as well as the routing of all wiring. Secondly, permits and inspections. Obtain all necessary permits from the local building department before beginning the rewiring work. Schedule inspections at various stages of the project to ensure that the work is being done in accordance with code requirements. Thirdly, professional installation. Hire a licensed electrician to perform the rewiring work. A professional electrician will have the knowledge, skills, and equipment to complete the job safely and effectively. Fourthly, whole house surge protection. Consider installing a whole house surge protector to protect the electrical system from voltage spikes. This can help to prevent damage to sensitive electronic equipment. Fifthly, energy efficiency. Use energy efficient lighting and appliances to reduce energy consumption and lower utility bills. Consider installing a smart thermostat and other energy saving devices. By following these guidelines, you can ensure that the fire-damaged wiring is properly inspected, repaired, or replaced, and that the electrical system is safe and reliable.